Hello and welcome back to Boxers Shorts, where we take complicated ideas from GCSE Sciences and try and explain them nicely and simply and give you guys some practice to do on them as well. Today we are going to be doing electrode half equations, which is the fourth video in the series on electrolysis. The first video, you deduced ionic formulae. The second, I introduced the idea of electrolysis. And the third, you did half equations, and today we are going to be looking at how those half equations apply to electrolysis. Now I'm going to put some questions up on the screen for you to do. Now these questions are what we call prerequisite. They are required in order to understand what you're going to do today. So if you haven't done video 3, i.e. the one about half equations, you're not going to be able to answer these questions, and this entire lesson will not make any sense to you whatsoever. So if that's you, stop this video, go back to the one before this one on the playlist and do that now. Okay, here are the questions. What I would like you to do is in a second, you're going to pause your screen and do the questions yourself. You're going to write down your answers. Do that now, please. Pause the screen, write down your questions. Okay, you should now only be listening to my voice if you have done those questions. And I realized that when I gave the instructions, I said write down the questions instead of write down the answers. So just to be really clear, if you have not done the answers to these questions, pause the video and do them now. If you have to do them, then you can carry on listening happily. So we had to write a half equation for the formation of sodium ions from sodium atoms. So I know that I'm starting with a sodium atom. So that's just going to be an Na. And I know that I'm forming a sodium ion like that. Now what that means is that the electron is being lost. If I'm going from a sodium atom to sodium ion, I'm losing an electron, and that's going to go over there. And again, if you're not fully understanding that process, then the right thing to do is not to just go, oh yeah, I think it'll be all right. The right thing to do is to go back to the previous video and make sure you've done that. The next question says formation of sodium atoms from sodium ions. So in this case, I'm forming a sodium atom, which as we know has no charge, from a sodium ion. Now if a sodium ion with a positive charge is going to form a sodium atom with no charge, then the electron is going to be gained over here. Now the next question is a half equation for formation of chloride ions from chlorine molecules. So I know that I'm starting, as per the last video again, I know that I'm starting with Cl2, that's my chlorine molecule, and I'm going to be forming Cl minus. But obviously if I've got two Cls here, I have to have two Cls over there. And again, this is what we did in the previous video. If I've got the negative charge over there, then I must have negative charges over here as well. So these chlorine atoms within that molecule must be gaining electrons. How many electrons? Well, 2. Because I've got 2 atoms, each one is going to gain 1 electron, and I'm going to make 2 chloride ions. And then here, I need to form chlorine molecules. So I'm going to make Cl2 from Cl minus. Obviously, then I need to have 2 Cl minuses, and my electrons are going to now be on this side. Each of these chloride ions loses 1 electron, and then they buddy up to form the molecule, and I lose 2 electrons. Like I said before, if you can't do these, then don't waste your time carrying on with this video. Pause right now, go back to the previous video on half equations, do that for the first time or again if you need to, then come back to this one. Now let's go back to our drawing of electrolysis. So let's say I'm doing electrolysis on sodium chloride. So I'm turning sodium chloride into sodium and chlorine. Now the first thing we're going to do is we're going to write a symbol equation for this. So what I'd like you to do is deduce the formula for sodium chloride. So tell me what the formula for sodium chloride is. If you need to think about it, that's fine, pause the video. If you've thought about it and you think you've got an answer, you're going to call out your answer on 3. What is the formula for sodium chloride? 1, 2, 3. NaCl. I'm just going to clean that out to make it super abundantly clear. NaCl. And actually, do you know what I'm going to do? I'm going to put some lines on so that my writing is a bit clearer, because at the moment it's a bit shady, well, sketchy, dodgy, if you will. So I'm just going to write NaCl nicely on the lines there. And that's going to form sodium, Na, plus Cl2. Write these down and balance this equation. Write these down and balance this equation, please. Pause the video to do that. Okay, you should only be listening to my voice now if you've written them down and balanced the equation. And you should have put a 2 over there and a 2 over there. If you can't remember how to balance equations, that's fine. I've got a video for you. Just go to Box of Shorts, Balancing Equations, and you shall find it. Now, of course, I need to think about the state of each of these. So if they're solid, liquid, gas, or aqueous. Now, this cannot be a solid. I want you to think about why it can't be a solid, and you're going to call your answer on 3. Why can this not be a solid if I'm doing electrolysis? 1, 2, 3. I'm hoping you said because it won't conduct electricity. A giant ionic substance won't conduct electricity unless it is what? Call out your answer on 3. What does a giant ionic substance need to be before it conducts electricity? 1, 2, 3. I'm hoping you said liquid or solution. So molten or solution, liquid and molten meaning the same thing. So in this case, we're going to start with liquids. It's a lot easier. In a future video, we'll do solutions. They're a bit more complicated. We're going to form sodium. Now, in reality, it's going to be quite warm, so the sodium will form as a liquid. We're just going to keep things simple for the minute and assume that it comes off as a solid. Again, let myself down with the poor handwriting there. And chlorine comes off as a gas. We're not going to go into this in detail, but I'd like you to think about how I know that chlorine is a gas. Think about your answer. Why is chlorine a gas? And I'd like you now to call out as much of the it's going to be quite long. So I tell you what, actually, why don't you write down your answer to this question on the side of your page or wherever. How do I know that chlorine is going to be a gas? Pause the video and write that down. So you should have written that down, and you should have broadly 3 points. So you should have, I'll write it over here. Chlorine is a gas because, point 1, it is a simple molecular substance. Now, some of you will have written nothing because you didn't even know where to start. Well, if that was you, I've given you somewhere to start now. Pause the video and write the rest of it. So chlorine is a gas because it's a simple molecular substance. It has weak intermolecular forces of attraction, or weak forces between molecules. Either is fine. And then your final point there is require little energy to break. Don't write easy to break. Write they require little energy to break. And we're not going to go back over that in detail because that is from an earlier unit on structure and bonding. If you need to, pause the video to mark and correct your work. Okay, going back. So we've now got our equation and all these substances being used, being produced, and their state. So we can start setting up our electrolysis apparatus. We'll start with, I wonder how thick that's going to come out. Oh, look at that. We'll start with these two things over there. Like this. What are these called? I'd like you to call out your answer to what are these called on 3. 1, 2, 3. They are called electrodes. And of course, we have a positive and a negative electrode, and we looked at that 2 videos ago. What is the name for the positive electrodes? Call out your answer on 3. What is the name for the positive electrode? 1, 2, 3. Anode. And what is the name for the negative electrode on 3? What is the name for the negative electrode? 1, 2, 3. Cathode. Good. I put these in a nice big beaker. And inside the beaker, I put substance. Now, in general, when we do electrolysis, what is the name of the stuff that goes in here? In general, so not this particular example, but in general, when we do electrolysis, what's this stuff called? 1, 2, 3, electrolyte. In this case, in here, I've got my NaCl as a liquid, like that. And what I'm actually going to do is I'm just going to pull this and move it to underneath, because I'm going to use the area on top in a second. No, go away. All right, how are we getting on? All right, so we've got the positive electrodes, the negative electrode, the anodes, and the cathode. Very good. Now, in this liquid we looked at last time, we have all the ions that are free to move. We have two types of ions in this liquid, in this electrolyte. What are the two ions that are in this electrolyte? Call out your answer on 3. What are the two ions that are in this electrolyte? 1, 2, 3. I'm hoping you said Na plus ions and Cl minus ions. And they're liquid. Okay, so they're free to move around, they're free to swash around in here. So I'm going to draw them inside little bubbles, as we've done before. Now the Na plus is going to go to this electrode. Now the word go to isn't a good word to use here. There's a better word that we've spoken about to use. What word is better than saying go to? The Na plus is going to go to this electrode. What word is better? 1, 2, 3. I'm hoping you said attracted. The Na plus is going to be attracted to this electrode because this one's negative and this one's positive. What is going to happen at that electrode? Now, what I want to do is I want to kind of zoom in. We'll do this in purple. I want to zoom in on what the surface of this electrode looks like. So over here, I've got the electrode. That's the electrode. And over here, on the outside, I've got my Na plus. Now, what a negative electrode is, what it means is that it's got loads of excess, it's got loads of extra electrons. So all over this electrode, I've got lots of E minuses, lots and lots of E minuses. That's what makes it the negative electrode. The Na plus is attracted to this electrode where it picks up one of those negative electrons, which means it goes Na plus and it picks up one of these electrons and it forms Na like that. And that is all happening at the cathode. Now, by the way, if you're writing this stuff down, stop, okay? I don't want you to write it down now, okay? You can write it down when I'm done. I'll give you time, I promise. That's what's happening at the cathode. The Na plus is being attracted to this kind of negative electrode, and it is picking up an electron from there, and it is going off, coming out as just pure Na. Now, that, by the way, is exactly the same as what we did over here. The Na plus is gaining an electron, and it's becoming pure Na. That's so cool. Now, what happens at the other side? So at the other side, what I'll do is I'm going to draw my chloride on the other side, just over here. It can go to either side. I'll just make it clearer what I'm trying to do. It'll go like that. And again, we'll explode this. Oh, what on earth just happened there? My bad. We'll explode this to zoom in and see what's going on. Like so. Again, we've got the electrode and we've got the Cl minus. Now, this electrode doesn't have lots of electrons. The whole point is that it's missing electrons. It's got very few electrons. So it's not that, I'm not going to draw anything there because the whole point is that it doesn't have anything. This one has got loads of electrons and this one doesn't. So the Cl minus is going to go here and it's going to come off as beautiful Cl atoms, and it's going to have lost an E minus. But it's a bit more complicated than that, isn't it? because when we go back to here, we see that actually it's got to be 2 Cl minuses to form Cl2. Cl, chlorine, doesn't exist as single atoms. It exists as molecules like this, which means that I've actually got to lose 2 electrons, and I've got to start with 2 chloride ions. So I'm going to explain that again, don't worry. I get 2 chloride ions, each one loses 1 electron, and they then bond together to make that. We could do that because it's a bit more complicated. I'll show you what that looks like as a dot and cross diagram. You'd have your essentially a Cl with 8 electrons in the outer shell and a negative charge, and we'd have another one of those, exactly the same, with a negative charge. Both of those would go to our electrode, and they would come off oh, sorry, I've done that wrong. It's not double bond, sorry. And they'd come off looking like this. And there would be 2 electrons left over. So here I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So in total, I've got 16 electrons. Up here, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 E minus, and the other 2 are over there. Okay, so I don't need to do that with the sodium because it's a lot simpler because there are no 2's involved. It's just 1 of everything. But here where we've got 2 chloride ions, they both go to the surface of the electrode. The anode in this case, it goes to the surface of the electrode. They lose electrons and they then buddy up to form Cl2. So that of course is Cl2, and this of course is 2 Cl minus, where I've got 2 Cl minuses. So I hope that kind of makes a bit of sense. And if I were to write that as an equation, then I would have 2 Cl minus forming Cl2 plus 2E minus. And of course, that is identical to what I wrote over here. So this is identical to that. Happy days. This is what happens at the anode. This is what happens at the cathode. The only step left for us, I'm just going to get rid of that because it's ugly and it's getting in the way. Excuse me. The only step left for us is to put these state symbols in. Now, what I didn't kind of point out here is that the liquid level is like this, right? So the sodium here is in the liquid, and the chloride here is also in the liquid. They go to the electrodes and they form a gas which is above the liquid. So we'll put a state symbol of an L over there and a G over there, and we'll put an L over there. And like I said before, it's a bit more complicated with sodium, but we'll just assume it's a solid for the minute. And there you have electrolysis plus half equations in a nutshell. What I would like you to do is pause your screen and get this down as a note in your exercise book. Okay, you should have got that down as a note, and that should help you in future questions. And let's go have a look, because I think what I'd like to do is some kind of worked examples. So I've got this kind of table that over the course of this lesson you're going to fill out. Actually, you know what I'm going to do? I think I'm going to make this table a bit neater. So let's get rid of that. Let's just bring this in a bit so we can zoom in a bit more, and I can make it a bit bigger for you. Hopefully that'll be enough space for us to work with. But I'm conscious of the fact that some of you might be doing this on your phones. So I need to be as kind of small as possible. So let's say I'm starting with lithium chloride, LiCl. I'm just going to write its name down as well. So lithium chloride. Now the positive ion involved here is, of course, Li plus. If Li plus is the positive ion, what I'd like you to do is tell me what the negative ion is on 3. 1, 2, 3. Hoping you said Cl minus. Now the substance formed at the cathode. Now remember that the cathode is the negative one. Remember that the metal is always formed there. So I'm going to get lithium just like that. At the anode, what am I going to get? Call out your answer on 3. What am I going to get? The anode, 1, 2, 3. Some of you will have said Cl. Some of you would have said chlorine. The correct answer is, of course, Cl2. Chlorine molecules, or Cl2. The cathode half equation, that's the one here where I'm forming the lithium. So I know that I'm going to be making lithium and starting with Li plus. And I know that at the cathode, we gain electrons. So lithium ion plus an electron goes to lithium. Now the anode, I know I'm starting with Cl minus, and I know that I'm forming Cl2. So as before, I know that if I've got a 2 there, I need to have a 2 here. And if I've got 2 negative charges on this side, I need to have 2 negative charges on this side as well. Voila, it is that simple. What I'd like you to do is don't do all of these for yourself now. You're going to do them in a minute by yourself. You're going to copy out that table and get on with it. But what I'd like you to do is first copy out the table, and second, just do this first one here. So get down the one that I've done, sorry, and then do this first one, and then we'll pause and make sure that you got it right. So what I'd like you to do is 3 things. Copy down the table, do the first row, and then do the second row, and then pause. Sorry, and then press play. So pause that now, copy the table, do the first row, do the second row. Okay, you should only be listening to my voice if you've both copied down the table and done this first row and this second row. So in this case, I've got magnesium, you're going to be marking your work, 2 plus, and I've got negative ion of, again, Cl minus, not Cl2 minus. Okay, I've still got, it's just Cl minus. Okay, so again, just to recap that, that's because I've got an Mg2 plus, 1 Cl minus like that, 1 Cl minus like that. That means I've got an Mg2 plus and 2 Cl minuses. If you wrote something like Cl2 minus like that, that is definitely wrong, because that means you've got something, where you've got those bonded together. So I should draw those circles touching. And then, like, I guess some overall charge of minus. This thing doesn't exist. This is totally, totally wrong. Okay? It's Mg2 plus and 2, you can either write 2 Cl minuses or just Cl minus. Doesn't really matter at this point. What substance is formed at the cathode? That's the Mg. At the anode, so that's going to be your Cl2. Cathode half equation, well, I've got Mg2 plus, and I'm forming Mg, so I must be gaining 2 electrons. And in turn, at the anode, is going to be exactly the same as the previous one. I'm going to get 2 Cl minuses, forming Cl2 plus 2 E minus. If you got that right, well done, excellent job. If you didn't, then I suggest you go back to my worked examples and to the diagrams that I've been drawing and try it again until you can figure out where you've gone wrong. If you're happy with that, I'd like you to pause your video and only press play once you have done all of these questions. So, filled out that table in full. So I'd like you now to pause your video and fill out the table. Okay, you should only be listening to my voice if you've now filled out the table in full. And what I will do is I will start working through. And as we've done before, if at a certain point you realize, oh, I've made a mistake, stop the video and then go back to all the ones that you've done and see if you've got that mistake elsewhere. It's likely that if you made a mistake in 1, you've made a mistake in 2, 3, 4, 5, and 6 as well. So it's really important, if you realize where you've made that mistake, you just stop the video and redo the questions rather than sit here and watch me correct the same mistake over and over again. It's a waste of your time. So I'm going to do these quite quickly. So I've got, oh, I don't know why it does that. Al3 plus, I've still got Cl minus, I'm going to form Al, Cl2, so Al3 plus, and in this case I'm going to have 3 E minuses forming Al. And again, this is going to be identical on that side. For Na2O, I've got Na plus and O2 minus. I'm going to form Na, and I'm going to form O2. If you wrote only O, stop the video now and make your correction here, because you'll have made a mistake there as well. Remember that oxygen as a gas is O2, so I'm going to have Na plus E minus forms Na, and over here I'm going to have two O2 minuses forming O2, and in this case 4 E minus. And again, if you don't know how to do that, go back to the previous video where we did the half equation for oxygen. A plus N3 minus, I'm going to form K, I'm going to form N2, and again, if you didn't get that, go back, same rule as before. And in this case, I'm actually going to be losing 6 electrons because I've got 2 N3 minuses, I've got 2 nitrogens, each one has 3 extra electrons. So if each one loses 3 electrons, I get 6 overall. NaCl is actually the one that we've done. It's just a nice way to revisit something once you've had a chance to sort of forget it a bit. So we'll have B2O3, got B3 plus, O2 minus, sorry, shouldn't come up, and I'm going to be forming B and O2. So B goes from B3 plus, add 3E minus to B, that's boron, and 2O2 minus, forming O2 and 4 minus. Here, I gave you these two, I didn't give you anything else. Hoping you worked out that that should be, oh, that's for the next video, don't need to see that yet. KBr, K plus, Br minus, then you should have K plus and E minus forming K, and here you should have 2 Br minus forming Br2 and 2E minus. And there you have it. You can now write half equations for the various electrodes when doing electrolysis on a liquid. I'm hoping you're feeling a bit more confident in that now. I'm hoping you understood, and I'm hoping you got all of these correct. And on next video, we'll be applying this to the very specific example of the electrolysis of aluminium oxide. As ever, thank you for listening, and I look forward to seeing you again.